Permit me to introduce to the class Engineer Adeyemo Festus Adeniyi, one of us who is going to anchor this training workshop on the statistical analysis. It's a top-up class, we called it, because we had a session, I think, early this month, and we promised to have a top-up class. So on this note, also permit me to read briefly the bio sketch of our resource person. Engineer Festus Adeyemo, fondly known as Vindicated Professor Niyi, BPN, is a forward-thinking Nigerian chemical engineer and seasoned academic technologist with over a decade of hands-on experience in process optimization, design simulation, and industrial experimentation, with a long foundation in chemical, petroleum, and environmental engineering. He currently serves as the University of Lagos and is pursuing a PhD in carbon capture and utilization, CCU, aimed at transforming emissions-heavy processes into economically viable, low-carbon solutions. His research interests span process intensification, green chemistry, environmental remediation, polymer innovation, and carbon capture and utilization, CCU. His ongoing doctoral research focuses on developing advanced CCU strategies to reduce the carbon footprint of the petroleum industry, aiming to contribute Nigeria's energy transition and economic diversification goals. He has collaborated on numerous innovative projects, including waste valorization, bioplastic production, biodiesel synthesis optimization, crude oil refining system design, and groundwater contamination modeling. He has authored several peer-reviewed publications and book chapters on topics such as heavy metal remediation, biofuel production, and wastewater treatment. As a certified Scrum Master, project manager, and AI in chemical engineering learner, Engineer Adeyemo blends engineering rigor with modern digital tools to drive impact in academia and industry. His technical leadership has been critical to accreditation achievements, laboratory revitalizations, and process safety optimizations within University of Lagos. Outside academia, VPN is a multilingual educator and a respected voice in the African blockchain space. During the COVID-19 pandemic, he taught Ethereum and decentralized finance to thousands across 3 continents. He was among the early pioneers of the Pi network and played a key role in using crypto-based. I want to quickly jump to the educational background. I will put this on the platform for us to read so that we save our time. Yes. Education background, he has PhD Chemical and Polymer Engineering, MSc Chemical and Polymer Engineering, BSc Chemical Engineering with class honor. And then he also had the HND and ND background, selected certifications, Google project management, writing in the sciences, and all of you. So we are going to put this on the platform for us to read, and then we can by this save our time. Thank you. Engineer, you can take on from where I have stopped. So we can start the class.
Thank you very much, everybody. Please,
are you with me, sir?
Yes, I'm here. Can you hear me, sir?
Hello? Yes, I can hear you.
Thank you very much, sir. I really appreciate you.
Yes.
Appreciate organizers and the committee for counting me worthy to take this class. Please, I would like to employ every one of us to mute our mic right now so that we can have a free class. This section is recorded also to help us rewatch, especially for those that one way or the other could not make the live class. They can always rewatch, or perhaps there are some points that you might want to look at again to give you an opportunity. So if you can mute your mic, by the time you are rewatching, it will be a better production for you. Yes, I'm going to make it some theory and some practical. For day 1, And day 2, it will be basically all practical throughout. For some of us that have our laptops with us, we are going to have some practicals today and some theories as well. So that will serve as an appetizer to those that don't have their laptops here today, so that when we are coming tomorrow, where we are going to have a full-blown practical, okay, everybody can get ready. But today, we're going to have some theory to give us a theoretical background of statistics and also do some class exercise, and I'll give you some take home for you to do. Also, I would like to let us know that I've dropped the data that we're going to be using in the course of this training on the group. You can see the data on the group. I dropped it in a Word document. It has about 3 or 4 tables. So I'm going to be using the first one for exploratory data analysis. And the second one, I'm going to be explaining about full factorial design. So this is simple statistical data analysis using Minitab for scientific communications and policy formulations. So why do we have to do this simple statistical analysis? Okay, so we want to see the essence is to introduce participants to fundamentals of the essence of this training is to introduce participants to the fundamentals of statistical thinking and data interpretation, to provide hands-on training on the use of Minitab, focus on design of experiments and response service methodology, to empower participants to generate and communicate data-driven insights for scientific reporting and policy decision-making, and basically to bridge the gap between statistical analysis and effective communication through visualization, data interpretation, and actionable recommendations. Now, the role of statistical analysis in scientific communication and policy making are evidence generation. It validates hypotheses, supports scientific claims, and guides experimental conclusions. Other roles are decision support, transparent and accountability, optimization, and policy evaluation. So we're going to have an overview of this Minitab as a statistical tool. All right. So you will see that Minitab is a very friendly but powerful statistical software used in the academia, industry, and governments. It provides an interactive environment for performing descriptive and inferential statistics, DOE, regression and ANOVA, control charts, and quality improvement tools. It's also used for graphical analysis and visualization, predictive modeling, and optimization. So why Minitab? We are using Minitab. We chose to train on Minitab today because Minitab is intuitive to users, both beginners and advanced users. Okay. It also has specialized tools for DOE, response service methodology, and it's ideal for experimental design, process optimization, and scenario testing. It's also seamless. It has seamless visualization of statistical findings through plot, charts, and dashboard. So we believe that with a strong support for quality scientific engineering, Six Sigma, and policy experimentation that you have from using Minitab has really driven us towards using it as our statistical tool. So the real-world case use for Minitab in science and engineering teams, they use Minitab to test materials and optimize performance. Health departments use it to analyze intervention outcomes. Policy analysts use it to simulate alternative scenarios and predict social outcomes, while researchers use it to design experiments, analyze complex data sets, and publish high-quality scientific papers. And some of these reasons are why we are gathered here in this workshop. Fundamentals of statistical thinking. A number of us had done statistics in our foundational class, maybe in secondary school, and even as year 1 or year 2 courses in our university, even though our core courses are not statistics. So this section is going to provide us with a refresher course, a rethink, all right, in the foundation of statistics. So number one thing you want to look at are data types, variables, and measurement scales. Okay, so what are data types you find in statistics? One, you have quantitative data, which are also numeric. You have them as continuous. Okay, they can take any value within a range, like weight, temperature. You also have discrete. Those ones are countable whole numbers, like number of people, number of defects. We also have qualitative. Those ones are categorical data. They are nominal. That is, they have categories without inherent order like gender, country. We also have ordinal. Those categories with logical order like satisfaction level, class ranking, etc. So when you know the type of data types or data sets that you're feeding into your app, whether Minitab or whatever app you choose, that will help you to form a background for thinking how the app is going to perceive your data and how you're going to analyze it. So nominal data they have classification without order, like I mentioned before. Ordinal are ordered categories. We have interval, like they are ordered into meaningful differences, but no true zero, like temperature. We have ratio, like interval, but with true zeros, like height, income. You know, your income can actually be zero. So incomes can actually have true zeros. So this forms the measurement of scales. Please, I won't be admitting anyone again, please. Thank you. I need to focus on this. So, like I said before, understanding scales ensures correct choice of charts and graphs. Like many people will say they don't know how to use these charts, I've forgotten statistics. But when you understand the scale that you're using, then you'll be able to choose your charts and your graphs properly. You also have the right selection of statistical tests, like you will know whether you're using parametric, or non-parametric. You also be able to have your data coding and transformation properly. So the next you want to look at is exploratory data analysis and descriptive statistics in Minitab. I hope you are following. So this very class now, we are going to have a practical. Please, if you have a laptop there, please make sure you launch your Minitab right now. We are going to do some exercise in this very session. Like I said, I intend to have some theory and some practical. So the theory is to give you the foundation, which we have looked at, the statistical thinking type of data. Now, exploratory data. What does it do for us? This involves summarizing and examining data sets to detect patterns, identify anomalies, test assumptions, and check data quality before applying more advanced statistical techniques on this data. All right, the key descriptive statistics, the key reasons for doing all of this is to measure, okay, to have measure of central tendency like mean, median, mode. To have measure of central tendency like mean, median, mode, and also to have measures of dispersion, range, variance, standard deviation, interquartile range, and also to check the shape of your distribution, okay, to see how the skewness or the kurtosis, and also other kind of parametric checks you may want to see. Maybe you want to see the minimum, the maximum, and the percentile, etc. So why does this matter? It helps, exploratory data analysis helps us to detect outliers or inconsistent data, helps us to check for normality assumptions, and also support decisions on transformation or model types. So in Minitab, to get this done, so we are going to navigate into stats. So let's go to stats right now, and then we'll click basic statistics, then display descriptive statistics. Then we select our variable of interest. We output choosing summary tables, confidence intervals, and basic shape indicators. Okay, then we can customize our output to specific metrics relevant to our analysis. But in this exercise we're going to have now, we are going to choose all the output. So we look at it because we are learning. We see how everything looks like and we see what we can do with them. So are we ready? So let's move into our Minitab right now. This is the Minitab, and then this is the data I sent to us. Hope you can see my screen. So this is data I sent to us. So this is data for exploratory data analysis. This data, see what I copied? I copied it from here down. Okay, so I copied from here down. This data is for exploratory data analysis, and the reason is to check for inconsistency, outliners, and to be sure that this data is in tune, like has every it has the right distribution before I can now use it. In case it does not, I'll have to clean out the noise or any kind of outliners. So after copying this data, then I paste it here. I hope you can see that. Okay. So what the step in the slide says is that you should come to start, but you cannot come to start without pasting the data here, like I just did. All right. So after pasting data, you come to start, then you come to basic tests, basic statistics. Okay. Then you come to display descriptive statistics. All right. So when you get there, you can pick all these factors. These are factors. C1. So you press down your shifts, okay, and you do C2, C3, C4. So that way you can highlight everything, and then you can click select, okay. So then you can now come to statistics, okay. So I said because we are learning, I want us to pick all. But if you have a preference to whatever you want to check on the exploratory data, you can pick your preference here, maybe variance, deviation, mean, skewness, kurtosis, and all of that. But for the purpose of learning, I clicked all, so we can actually see all the parameters, how they play out on the graph, to see the visualization. Now, when you're learning about data analysis, visualization is very key. So now we are learning about visualization. You need to learn on what you are visualizing. How does it look like? How do I display it? And what are outliners? So you come to graph, and then already we checked all the boxes because I want to see all the descriptive statistics. All right. So after that, I click OK. So when I'm done with that, the next thing to do is to activate it and click OK. Then you see what this exploration will generate for us. Are we ready to go? Are we ready? Okay, let's go. Okay.
Yes, sir.
So can we see this? So this is the data that we have. Sorry, this is the descriptive statistics that we have from our raw data. So you can see the histogram. This histogram, C1, you can see C2, you can see C3, C4, that's for histogram. Then you can see the normal curve. Can you see the normal curve for this? Can you see that the curve is well distributed? Also, this one well distributed. So, can you see this also? Okay. So, if you look at this, you see that they are almost evenly distributed. And here also, but it's kind of skewed a bit towards this side rather than to be here. So, this is giving you an information, a preemptive information, exploratory information about your data before going ahead to analyze it. You can see here it's showing some clusters